Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today what I have for you is a question that I'm looking to examine. The question is test generation a good idea? I have heard about test generation for a long time because there are a few situations and I'm going to go through them. But basically, test generation has been around for some while. There were some Microsoft tools that were doing that, including with access to private members, which was really strange, and not a very good practice from my point of view. But it was useful sometimes, and honestly I'm interested in this balance between usefulness and actually in the trade-off for every practice. We are always trading off something for something else. So because of that, I'm interested in this question, and I've identified 3 typical situations for today. Since AI and LLMs and Copilot has captured a lot of the imagination of software developers and is starting to get some traction, not as much as perhaps the AI companies would want, but it seems to have caught a little bit. This question has come more and more because you can basically use an LLM to generate tests for you once you've written the code. So this is the first situation. I finished the implementation, now I have to write the tests and I don't like it. So why not use some kind of generator, and why not use some kind of AI generator, since they will do a good job, hopefully. Or at least get rid of some of the work for me, do some of the work for me. The second situation is I have to change some existing code and I'm afraid that code either doesn't have tests or has tests that are not reliable. So I could use some generated tests to help me. And the third one is something that I've seen boasted more and more, is like I can use AI now, so I can use LLMs. So yeah, it will generate everything for me. And let's examine each of these in turn, because I think that they are very different situations and they are worth discussing separately. The first situation is I finished the implementation, now I have to write the tests and I don't like it. Now, the problem with this is that what's the goal of tests? Tests are supposed to be a second way of checking that what you have implemented is actually correct. Tests are not supposed to be testing starting from the assumption that everything you've implemented is correct, and now we assume that is working perfectly and we just need to write the tests. No, the goal of tests is to have a secondary checking mechanism. We want tests to capture bugs as early as possible, and because of that we want to write the test from the perspective of looking inside the system, from the outside. Like, what is this behavior supposed to do? What are the inputs and what are the corresponding outputs that I'm expecting? And what about this edge case? And what should happen in that particular situation? And these are turned into tests. So the goal here is not necessarily, you write the tests and then you write the code and you are done, but now you have to write the tests because it's something that we have to do because it's the manager is asking me to do it, or because it's in our guidelines, or consultant told us to, or something like that. the goal of tests is to verify the system. And so you have to think about tests in a different way than you think about the implementation. That's one of the hardest things to do when you try to do unit testing correctly. And this is why it's best if you write the tests first, because if you write the tests first, you don't have an implementation yet. And it's more likely that you'll get disconnected. Although in many situations, developers fail at that. I mean, developers are very connected with their idea of implementation instead of being open to the possibilities, especially early on. And that's part of the training, and that's part of why it's so difficult to learn things like test-first programming or test-driven development. So the basic problem with this is that you will have bugs in your implementation, you'll generate tests, the tests will institutionalize the bugs, and hopefully they will be caught later on, but then why are you still writing tests if the only thing that the tests are doing is doubling your code? That's not what they are supposed to do. They are supposed to be on the other side, checking your code. So, and maybe this is also why people or developers find it, some developers find it annoying to write tests, because they figure that, it's working perfectly. I verified it, I've tested it, now I'm just making sure that I have this thing in place because it's needed. Instead of seeing tests as a helpful mechanism, as a double checking mechanism. I think I've seen recently Jason Gorman saying something on the lines of generating tests from the implementation is like giving grades to an exam based on the solutions to problems given by the participants to the exam. It's kind of the same thing, right? If you go to an exam, the teacher is not looking at, okay, so 80% of you answered this, so this means that this is the right answer, and because of this, we'll score this as correct. No. They come with a list of things that it needs, with a checklist, and they verify against that checklist. That's how you do it. It's the same with tests. So, and the second thing, which is more hidden, tests help you learn more about the code, about the behavior, about the domain, about software design, about a bunch of different things. And every time developers kind of skip this, or they do it just because it's needed, or, do it just to get rid of the task, to get rid of it as quickly as possible because it's a chore, you are missing the learning part. And the learning part is what will make you more and more relevant in your code base. And that might be particularly interesting in the future when more and more companies might look at, replacing some of the developers with AI tools. It's already starting to happen, so it might happen. And because of that, it's good to learn more and more about what the program is actually doing, how is it structured, what are some good design patterns that fit in your design, and so on. These are all things that matter more than just being able to write the code and the tests. Okay. The second situation is very different, because in the second situation, the statement is, I have to change existing code and I'm afraid. And I could use some generating tests to help me. The basic way to deal with the legacy code is the one described by Michael Feathers. And I think we've done a few videos on that and on an alternative method that uses pure functions to refactor. And there is a trade-off here, because so how would you start when you deal with legacy code? You need first to write some tests that are called characterization tests. The goal of characterization tests is basically to document and to fix in time the current implementation, the current behavior, actually, not exactly the implementation, the current behavior, including the current bugs. So in this case, if you generate characterization tests, there's no problem with institutionalizing bugs, because you will get rid of the characterization tests eventually. You'll replace them with faster, simpler, better unit tests and integration tests, and based on your testing strategy. But this initial step is very important because it serves as a safety net. These tests are not meant to cover everything, although you can do that. And even if they cover every line and every function and so on, they might not cover some specific cases anyway. So because of that, what happens is that if you refactor, you change something in the code, and one of these tests is failing, you know that you've done something wrong. But if you change something and none of the tests is failing, you don't know that you haven't actually introduced an issue by mistake. So these serve more like a signaling mechanism, and it depends a lot on the situation. Sometimes it's okay to generate the tests because you get faster to refactoring, and you can do that. Other times, writing these characterization tests actually helps you understand more about the code base. And now it depends a lot on where you are. Do you know well what that part of the code is supposed to do? If you do, because maybe you've been in a team, the team has been working with that, it's a part of the code that's particularly nasty, nobody's touching it, now you need to change it, and because of that, you are looking at these ways, but you have enough information about what it's doing. And in that case, generating characterization tests is a time saver, because you can go through that, and through that process end up with a test suite that you can use to move further. But if you don't know enough, by writing these characterization tests, you learn a little bit more about how the code works. So there's pros and cons. Maybe you can, in some situation, you might be able to generate these tests, make sure that they run, and then kind of refactor them in order to understand the production code, the legacy code better. That's also an option. But here, I have mixed feelings about this. I think I would use an assistant for this, but it would be really contextual, depending on the situation. So basically, if we were to summarize this, it would be there's a trade-off between the time it takes us to start refactoring versus understanding the code, which is also kind of an input for starting refactoring sometimes. So yeah, it's kind of a cycle. It's not a simple thing. But this is basically the trade-off. So if you believe that you can go faster to refactoring, and then it will be easier for you to deal with it, fine. Otherwise, might be a good idea to go a little bit slower and try to understand the code a little bit more. So writing the test optimizes for learning, generating the tests optimizes for time, basically. And this takes us to situation number 3, which is basically I now have LLMs, so I can use them to generate tests. And the problem here is kind of the line that I've been building on until now. It's once again, the question is, what will you know about the code after you do that? Because what you know about the code, about the product, about the domain, that's something that's helpful. That's something that's valuable in your organization. And that's part of your value. Now, will we be able to have LLMs that store this kind of organizational knowledge, institutional knowledge? I don't know. Right now, it's unclear, right? It's not very obvious that LLMs, let's say you feed an LLM all the code you wrote for a product, and then you start asking questions about it. What types of questions will an LLM be able to answer? I'm not really sure. I mean, presumably they will answer very confidently and sometimes very wrong. So the question is, if you let your LLMs be part of this work, can you extract this knowledge later on when you need it? Wouldn't it be better for you to actually have this knowledge? So I think the biggest trap we can fall into is to rely on these tools and then realize 6 months, 1 year, 2 years later that we know very little about our code base, that everything is stored in an LLM, and that we cannot extract that information out of it anymore. Right? And that's something that might happen. And honestly, the worst situation I've seen through the nature of my work, because I've been called in various contexts as a consultant, and I've seen various difficult situations for various companies. I've seen companies that were on the brink of bankruptcy. I've seen companies that were that had success, but then it wasn't going that well and they had to adjust their expectations. But honestly, for most of these, it's quite easy to recover. I mean, it's not easy. There are some hard measures that need to be taken, but often it's clear, right? Once you sort things out, you sift through it. It's just a matter of making the right decisions. Sometimes timing is very important, of course, and so on. But the worst situation that I've seen is when teams were working on code bases and they had no idea what was in that code base. Recovering the knowledge from a code base is incredibly difficult and time consuming. And there is no shortcut to it. And maybe we will be able to bring in an LLM, train it on our code base, ask questions, and move on. But maybe it will just give us wrong answers, that will just introduce more bugs, and we'll have no idea how to fix those because we don't know anything about the code. That's the worst case scenario. And if I worry about anything when I'm thinking about development teams that work on or code bases that have been around for a long time, and where people who created those initially, all of them left, and it's like the third generation of developers working on that code. the biggest problem is passing on the knowledge. That's the hardest thing. Because once you lose the institutional knowledge, it's very hard to recover it. So the question is, here we still don't know, but just my feeling right now is that it's quite risky to use LLMs and forgo your own responsibility of learning more and understanding what is going on in that code base. Now, if you can use an assistant to take some of the grunt work or some of the annoying work, so that it gives you time to do more of the learning, understanding, and so on, of the higher value work, that would be great, you know. So I have used successfully LLMs for translating code bases from a language to another. It's true, these are pretty small for our for various exercises, for various coding exercises, but it's quite something good, because it was something that I would do mechanically, but now it's faster with an LLM. So that's great. But I still write the first version. I still know what's in there. I still think about the concepts, about everything. So I think that's the biggest thing about this. It's, do we really want to outsource the knowledge about the code to a system that we don't know enough? We don't know enough about how it's working, why it's working that way. And we know that it is hallucinating. We know that it will give wrong answers. We know that it will never say, I don't know how to do that. So that's a big question. And of course, maybe today it's the easiest way out. And I won't blame you if you do it once or twice. But on the longer term, this grit, this everyday learning a little bit more about what's going on in your code base and in your product and in your project and in your domain, that's what makes you more and more valuable. And, you know, more power to you. I think you should invest in you and grow your own value in the organization. It's good for the organization, it's good for the users, it's good for you. So everybody wins. With this being said, there's an idea that I recently learned. So Andrei Alexandrescu gave an end keynote at a conference called Code Europe. And I watched that because I was looking, well, first of all, I'm a big fan of Andrei Alexandrescu. He wrote some amazing books, C++, mostly. He's had a lot of contributions to C++. And he's always quite entertaining in his talks. And this time he was talking about AI and code and programming. And one idea that he said is that once you have these systems, you can basically generate tests from two sources. So many people think that it would be a good idea to, you know, write the implementation, generate tests from code, and that's it. Now I have the tests. But what about doing it differently? You have your specification or your user stories, acceptance criteria. Generate the tests from those, and then generate the tests from the code and compare them. And that will give you an idea of how far the two are. Now, the thing with this is that it's not as easy as it sounds, because some of the style will most likely be different, right? So I have some questions there about the practicality of this. I still prefer to use test-driven development, test-first programming, things like that. I still prefer to write the tests before I write my implementation. And honestly, if you know how to write the test correctly, it's not that hard. I don't know why so many people struggle, but it's mostly about getting a good testing strategy, learning how to write the test effectively, learning how to decouple your tests from the implementation so that you don't have to change the tests every 5 minutes on every change in your code. And if you manage to do that and then remove duplication from the tests using things like data-driven tests and custom asserts and object builders, then everything kind of falls in place. You have tests that are 3 lines long, 2 lines long, 1 line long, and that's it. It's not that difficult, but it takes a little bit of getting used to. That's one thing I agree with. But if you want to experiment with this, I think this is an idea that is worth experimenting with. And I'm not dismissing it outright because there may be situations when it's actually extremely useful. Like I have heard about teams who are telling me we were given a project that was, so this is a code base and now rewrite this and in the new technology, whatever the new technology is, sometimes a different programming language and so on. And good luck. You have 3 months or something like that. But we know nothing about that code base. And now if you were to do this in the traditional way, you would have to go there, kind of understand it, maybe write some tests around it. There are ways of doing that, but honestly, all of them take a lot of work. And with this assistance, one of the things you could do is maybe you have some documentation. Let's generate some tests from the documentation and generate some tests from the code. Let's compare those. Let's see which tests we are keeping, first of all. And now we have tests. And because we have tests, you can use those to rewrite things. And we can actually translate from one language to another, from one technology to another using assistance, and now we can do that. So I can see situations where this can be extremely useful. It's an idea worth trying. And it's a practice that I think it feels like it will have its own niche, its own place where it makes sense. I wouldn't do it for software development, however, but, well, you do you. All right, so what do you think about all this? Do you generate your tests from the code? Do you hate writing tests for your code? Why do you hate writing tests? And what are your challenges with testing your code? We love comments, so leave us a comment, ask us questions, propose other topics for the next videos. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.